Before we talk about today's topic, which is zeroth power, let's understand some of the basics of exponents. So let's look at these two questions right here. So the first one is what happens when 2 is added to itself 3 times? So how do we write that? 2 plus 2 plus 2. And our answer would be 2 plus 2, which is 4. 4 plus 2 equals 6. So how can we simplify this and write? So this means that 2 is added to itself 3 times. That means 2 is added to itself 3 times. That is 2 times 3, which is equal to 6. So this repeated addition, we wrote it as a multiplication. So multiplication is nothing but repeated addition. If I say 4 times 2, that means 4 is added to itself 2 times, which is 8. Now let's look at the second example, which says what happens when 2 is multiplied by itself 3 times. When you read the question first time, you might just write 2 times 3. 2 is multiplied by itself 3 times, and we get 6. But is that right? Let's read the question carefully and try to answer. What happens when 2 is multiplied by itself 3 times? That means 2 is multiplied by itself, that is another 2, like that, for 3 times. So what is our answer? 2 times 2, that is 4, and 4 times 2 would be 8. So this is wrong answer. So how can we simplify this and write? So that is where we use exponents. So to show that 2 is multiplied 3 times, we can write this instead of 2 times 3, we write this 3 on top of 2. So that is how we show the exponent. So this is the exponent that shows that this 3 is being multiplied 3 times by itself, and we get 8. Also, you can write this exponent as 2 with the caret symbol and 3. Because if you're typing it on a keyboard, you won't be able to write 3 on top of 2. It is going to look like 2 and 3. You cannot take 3 on the top of 2. So instead of that, you write 2 with the caret symbol and then 3. It shows that 3 is the exponent of 2. We know multiplication is repeated addition, whereas exponent is repeated multiplication. For example, if I say 3 times 2, that means 3 is added to itself 2 times. So we get 3 plus 3 equals 6. And if I write 3 with 2 on the top, that is exponent, or we can write it as 3 with the caret sign and 2. That means 3 is multiplied by itself 2 times, and our answer would be 9. That we know that exponent is a mathematical expression that represents repeated multiplication. So how do we say, or how do we express this in words? If you see like 2 exponent 3, or you say 2 and 3 on the top, how can we say this? How can we express this in words? So you could say either 2 to its third power, or you could say 2 to the third, or 2 to the power of 3, or 2 raised to third power. because 3 is on the top. So 2 raised to its third power. So in this expression, 2 exponent 3 here, 2 exponent 3, 2 is called the base and 3 is the exponent, or we can call it index. Let's look at these two examples. So what is x exponent 5? How can we express it in words? X to the fifth power. Or we can say, like the second one, x to the fifth, or x to the power of 5, or x raised to its fifth power. And what does that mean? That means x is multiplied to itself 5 times. That's 1, 2, 3, 4, and 5. Let's look at the second one. And how can we express this in words? So first we say the base. Base is a to the nth power, because n is the exponent part. So nth power. Or we can say, like the second one, a to the nth, or a to the power of n, or a raised to its nth power. And how do we write this? So a is multiplied to itself, a times a times a, up to n times. So that's what it means. So n can be any value, and a can be any value. So a and n are variables here which can take any value. So a to its nth power is a times a times a up to n times. Now, let's get into today's topic, which is a number raised to its 0th power. To understand this, we need to understand how mixed operations involving exponents work. So consider a division problem involving exponents with the same base. Example, 3 to the power 4 divided by 3 to the power 2. So if we expand this, 3 to the power 4 means 3 multiplied to itself by 4 times. And 3 to the power 2 is 3 multiplied by itself 2 times. So in this one, so we have 3 and 3 are common factors on both numerator and the denominator. We can just cancel these out. So what we get here is 3 times 3. What is 3 times 3 in exponent form? It's 3 to the power 2, or it is 9. So what did we do here? So we can show this as 3 to the power 4 divided by 3 to the power 2 equals 3 to its second power. So what did we really do here? We took away the repeated threes from the top and the bottom. So when we take away something, how do we express? We express it as a subtraction sentence. So if we just look at the numerator here, we have 4. 3 is multiplied by itself. So which is 3 to its 4th power. And then we are canceling out 2 3's. So where do we show the subtraction? We cannot show the subtraction to its base because this is not addition. This is repeated multiplication. So we have to show this subtraction to the exponents, to the exponent part. So we took away 2. 3 multiplied by itself 2 times, that is an exponent 2 from exponent 4. And we get 3 to the power 2. So you can see here, so we subtract the exponent of the numerator, we subtract the exponent of the denominator from the exponent part of the numerator. And we get 3 to the power 2, so which is our answer. This relationship is actually a law in the exponents that says whenever you divide 2 or more exponents with the same base, your resulting exponent would be the difference between the exponents of the numerator and the denominator. Say, for example, x to the power 5 divided by x to the power 3 would be x to the power 5 minus 3, which is x to the power 2. Let's look at another example. Say 3 to the power 4 divided by 3 to the power 3. So if we apply this law, we get 3 to the power 4 minus 3, which is equal to 3 to the power 1. Now what is 3 to the power 1? Let's just expand this and see. So how can we write 3 to the power 4? 3 times 3 times 3 times 3 divided by 3 to the power 3 is 3 times 3 times 3. And we have these common factors. We cancel that out. We get the answer 3. So that is 3 to the power 1 is 3. So this leads to our next rule of exponents that says any number raised to its first power is the number itself. For example, x to the power 1 equals to x. Now let's look at some other examples. Say 3 to the power 1. What is it? It's equals 3. 4 to the power 1 equals to 4. Say a to the power 1 equals a. Now look at some other example involving division. What is 3 divided by 3? We know it is 1. Any number divided by itself is 1. So how can we write 3 in the exponent form? So we can write it as 3 to the power 1, which we just learned, that any number raised to its first power is the number itself. So we can write 3 as 3 to the power 1. And how can we write this 3 in its exponent form? We can write it as 3 to the power 1. And now, if we apply the division rule that we just learned in this course, how can we write this? As 3 to the power 1 minus 1. So our division rule says when you divide 2 exponents with the same base, your resulting exponent would be the difference between the exponent of the denominator and the numerator. So we get 3 to the power 1 minus 1. So with 1 is the exponent of the numerator, and this 1 right here, exponent of the denominator. So we get 3 to the power 0. So what is 3 to the power 0? So what is the value of 3 over 3? 3 divided by 3, which is 1. So this also should be 1. So 3 to the power 0 equals 1. Let's look at another example. Say 4 to the power 3 divided by 4 to the power 3. So any number divided by the same number by itself equals 1. Or we can prove this. So we can write 4 to the power 3 as 4 times 4 times 4 divided by 4 times 4 times 4, and these get cancelled and we get 1. What is the other way to represent this division problem? If you apply the rules of division of exponents, we can write this one as 4 to the power 3 minus 3, which is our division law. That says if you divide two exponents with the same base, the resulting exponent would be, the resulting answer would be, or the resulting exponent would be the difference between the exponent of the numerator and the denominator. So we get 4 to the power 3 minus 3, which is equal to 4 to the power 0. And what is 4 to the power 0? What is the value of 4 to the power 3 divided by 4 to the power 3, which is 1. So 4 to the power 0 is 1. So from this example that we see that 3 to the power 0 is 1, 4 to the power 0 is 1. That means any number raised to 0th power is equal to 1. This establishes our next law of exponents in our topic, which is any number raised to its 0th power is always 1. That is, x to the power 0 equals 1. Let's just quickly review how we establish this. We know that 1 is any number divided by itself. 1 can be written as a fraction, x divided by x, or y divided by y, or 2 divided by 2. So since here we are talking about x here, variable x, we write it as x divided by x. And how can we write x in exponent form? And that we learned from the other rule that any number raised to its first power is a number itself. So we can write x as x to its first power divided by x to its first power. And then we apply the division law that we learned, that whenever you divide two or more exponents with the same base, your resulting exponent would be base to the power 1 minus 1. That means the difference between the exponents of the denominator and the numerator, which is 1 here. So x to the power 1 minus 1 equals x to the power 0. And what is this x to the power 0? Which is 1. So we establish that x to the power 0 equals 1. So x can take any value. So it could be 1 or 2 or a -1. So it can be negative integers, positive integers, or fractions. Could be 1 over 2 to the power 0, which is also equal to 1. So always look beyond what you see. So that concludes our topic right here.